all my viewers and people who are seeing this presentation. Greetings, and today we will cover very important topic uh, that is scoring with analytical models for performance. So while in the field of business analytics, we make a lot of analytical models, and when we make a model, then of course then you have to score a data set with this or apply that analytical model to a real data set so that it can be used for decision making. And then before you apply these analytical models, you have to really check what is their performance. So today's topic on operation supply chain analytics related to scoring with business analytical models for performance. So let's start. So in a typical workflow of any data analytic project, if you see the typical workflow will involve first you understand the business. So once you have understanding of business, what is the nature, what is the key issue that you have to address within the context of particular business. So once you are clear about the issue, then you identify the data. You start collecting the data as much as possible. Then once your data is collected, you select what are the different variables in that data and what is their role. And then you look at the you explore the distribution of those variables, whether these variables, of course before you go that you have to make sure that this data you have is complete, there is no missing values, and it doesn't has any outliers. So all the missing values and the outliers have been addressed during this clean and transform process. So once you have this select variables, you look at the distribution and whether this distribution is normal distribution, this is a Poisson distribution, this is exponential distribution, or this is a uniform distribution. So once you are clear about the variable and their distribution, so that appropriate statistical techniques or formulas can be applied while building the model. So then you next is of course I told you just now that once you have this data has to be clean, and then you transform it for the statistical analysis. One example, like clean means that no missing values. If there is any outliers, those have been addressed, and only the the variables that need to be addressed, those are there. And in transformation, it means that you transform the data. Suppose like 0 1, it has to be yes or no, then it can be put coded into 1 and 0. And if there's a Likert scale, then it is like 1 to 5. Those numbers are there, proper scaling is there, and values lie between -1 to 1, or they lie in sigmoid function, or they lies between 0 and 1. So all those, that is part of transformation. Then next is once your variables are selected, you know what is the distribution they are following, and your data is clean and transformed, ready for statistical analysis. Then you build and tune your models. These are analytical models. So once your model is ready, next step is you evaluate this model for the performance. So you evaluated whether performance is good. Once it is found to be good, then you deploy that model on the actual data set or the real business problem based data set or issue related data set. Then you deploy that model for particular case, and then you take, of course, based on this, once you deploy, you take appropriate decision based on the output. And then of course you keep on monitoring the performance of that model, and you keep improving on the model. So model one built, it is not a stationary one time exercise. Of course you take a decision, then over a period of time you keep on fine tuning the model, improving the performance, and then use it for subsequent decision making. And let's be clear of, like, when you apply the process of applying a predictive model to a set of data, a new data, or an or a real business case data, is referred to as scoring of data. So scoring is nothing but process of applying a predictive model to a set of data. What are these predictive models? Of course, you have been you don't know them as models, predictive model, but you have been applying in statistics, you have been applying regression, clustering, decision tree, scale vector machine, and neural network models. So all of them are used in predictive analytics. They Predictive means you are predicting or classifying a thing as good or bad, or you're predicting a probability of something happening or not happening, or you're classifying something, so, or you're predicting outcome. So all these are based on the all these are predictive models using regression technique, clustering technique, decision tree technique. One thing that I'm missing here, beside decision tree, you can have random forest, which is a cluster of decision tree put together. And sometimes you also have boost, ADA boost method, SVM method, and neural network. All these are different type of predictive models, and you basically use them to predict probability of something happening, or classification of something. And when your models are ready and they evaluate, of course you have to evaluate the data before model sorry evaluate the model, and you evaluate them on either error metrics that consist of specificity and sensitivity. And once your model is built, you save the model specification in a file, which could be a CSV file, XML file, or zip file, and it contains all the model specification and all the information that is necessary to reconstruct the model. And then model score is then model file, whatever the XML or CSV or zip file that you have, then that file is used to generate predictive scores in other data set. That means you're scoring the other data set using a predictive model that you have built. So how to evaluate? So okay, so the either your model is a regression based model, or it's based on neural network, or it's based on SVM, or it is a decision tree model. So how to evaluate the performance? So there are basically four methods to do it. First is a confusion matrix, which is also called error matrix, that compares prediction with the actual answer. So one example is here, and then say what is actual in the training data set, or what is yeah. So this is what is predicted and what is actual. So actual is no is versus predictive is 39, but actual no versus what is predicted is 5. So this error is 5 here. What is yes in actual and also predicted is yes is 5, but what is yes but predicted is no is 5. Correct? So there basically we partition the data set, as you may already know, in three compartment. One is training, second is testing, and third is validating. So what we have to do is that training is basically used to training data set is used to train or build the data analytical model. Then you test it, test its performance on the test, and then finally on the uh, the remaining data set, you actually use it to and whatever the total performance is basically based on all three, but more or less what we normally interested is the testing, what is the performance in testing and the holdout. So a confusion matrix which compares prediction with actual answer. In confusion matrix we look at the error rate. Yeah, error rate is a proportion of observation for which model incorrectly predicts the class with respect to the actual class. Then it's also precision recall sensitivity of a model. They are the same thing. Some people call it precision, some call it recall, or sense. Some people call it sensitivity. Is the ratio of true positives to total number of predictive positives. Yeah, they could be true positive or false positive. What the total predictive positives? So proportion of it is called precision, and specificity is number of true negatives to total number of predictive. Sorry, this is a typo here. Predictive negatives. Yeah, what is suppose 0 to negative is predictive is negative is predictive is negative, but some people can put it positive. So other way it is shown here. The error matrix or confusion matrix is shown here. This is basically what it is, and basically what you are interested in error, overall error, and error should be as less as possible. So error should be less less as possible, and accuracy should be as high as possible. The second is the risk chart, which is cumulative gain chart. It plots the performance of model against known outcomes and used to identify suitable trade-off between efforts and outcome. So you can see here it's a risk chart, and basically it's normally put in whenever the binary classifications involved, and you can see this is the performance and this is the caseload, and you want to so some chart is here, that is something that is of interest. The more the area here under the curve, the more better it is. So if there are two lines, one is here and another one is here. So of course this line is better than the line here. So this model which gives this line is better. Let's look at the third performance criteria, which is traditional ROC curve. It's basically plots the true positive rate against the false positive rate, and it is also like risk chart. It is also built for binary classification. Uh, we look for as large area. So again, this is a curve like this, and true positive against the false positive. And what you're looking at, there are two models. Suppose this is model A and this is model B. So of course this is better because the area under the curve is more. And now let's look at fourth method is of course simply scoring the data set. So we score either the class, so model will either classify it, there's a probability, or it gives a predicted value. Yeah. So class probability, classification probability, or predictive value together with any variable. will be saved in a CSV, and of course I mentioned to you, you can also save it in XML or zip. So these score files, score of scores are saved in a XML, zip, or CSV file for action or further processing with any other tool. One key thing to note, will clarify it when we look at the example. In applying a dataset to a new dataset, applying a model to a new dataset, a new dataset must contain all of the same variables and have the same data types. So I'll reiterate, the same variables and same data set on which the model was built. So suppose, so you are scoring a new data set. In the new data set, the variables and the data type should be same as that on which the original model was built. Correct. Now we'll look at one example, and then things will be clear to you. Now let's look at the scoring process. That means building a model and applying it to the new data set. So we're looking a little bit more in detail. The scoring process consists of two basic steps. First is we build the model and save the model file. So this is step number one. You build the model using a data set for which the outcome of interest, often referred as target, is known. And how does a model, when you save the model file, it is basically, it expresses internally the set of numeric transformation to be applied to a set of fields or variables. Correct. So whatever the predictive variables, some numeric transformation happen to them, so that the predicted result can be obtained. So in this sense, the process of scoring data with a given model is inherently same as applying some function. There is a square root function to a set of data. So suppose when you save a model, it's suppose it's a model is just for finding the square root, and when you put it on it, now whatever the square root has to be done, that mathematical transformation will take place when you score it. So once you build the model and save the model file, then you apply the model to a different. So in this case, when you originally build the model for this data set, you have whatever you predict and you already know the outcome. But here in the new data set, the outcome is not known. Correct? So but here you obtain the predictive outcome. To obtain a predictive outcome which is not set as a new field in the data set. So once we apply that model to a different setup, we save the partial data set with the predictive outcome of interest, a new data set. Suppose we apply to a particular mailing list and people who will respond to our marketing email. So if it's a so the people who will positively respond, we are interested in that, and we'll save that data set of only the people who are the predictor is showing the positive response rate, and we save that data set as a new data set and then starts sending emails to them. Let's look at one example. So we'll use SPSS to show you an example. It's a direct marketing division of a company use test mailing to assign propensity scores to rest of their contact database. So they have a lot of customer contact database. They want to see whom to send emails, marketing emails. So they build up using SPSS. They build up a model. It's a model for people who are most likely to purchase, or it's a propensity to purchase data analytical model. And basically underlying method is a logistic regression model. So people who are high propensity, they are shown as 1, and people with low propensity are shown as 0. So basically it's a logistic regression model which is applied to variables, and dependent variable is propensity to purchase, and independent variables are multiple. I'll show you the data set. There are multiple independent variables, and data file we're gonna use is dm data is used to build the this .sav. This is in the SPSS format is used to build the model, and then the model is applied to another data file called dm data. The file that is code is called data file is dmdata.3.sav, which is again in SPSS. So without uh, opening much, let me take you through SPSS and show you how the thing really works. Yeah, so here is my SPSS. I open up SPSS and you can see the file that is opened up is dmdata.sav. Yeah. So now here there are multiple ways I can go about it, but let me easily choose. There's an option called direct marketing given in SPSS, and here I select within data marketing tab. So there's option improve my marketing campaign. Then select contacts. So I choose this option. Select contacts most likely to purchase. I double click it. Now you can see it gives me different fields that are these are different variables that are there in the data set. Yeah. So what I have to select is responded to. Yeah, response field. I choose here responded to test offer, and then I put different independent variable. Then I put them here. So in the field, I select response field, respond to test offer. Then here it says positive response value. I select yes, which is given as 1, and then I predict the propensity. So my predictive variables become age, customer ID, postal code, income category, education, year, gender, married, regions, and then sequence. Let me check if sequence has to be there. I think that we had used it in previous example, which has come here. So I'm not sure in this example if, yeah, sequence has not to be there. Look like this data set was okay. Now we have and of course customer ID. Okay, so these are predictive variables. This is the outcome variable. Inside we're using logistic and respond to test offer, and here we choose a file name. So I'll say direct marketing. And where do I want to save this file? I save this file on my desktop. Okay, and once I have this file, then of course I'll do settings. In settings we will validate the model, and we select model validation. Training data set is 50%, and we set the seed. We selected, we put the value of 2 million. Overall model quality and classification, minimum probability I'll put zero point 0.5. I look at 5% minimum probability. Does fair enough. Let me quickly check back. Okay, then I click next. Okay, then I'm looking at select scoring function. There are different scoring functions which are probability of predicted category, probability of selected category, confidence, and predicted value. Now, of course, normally I would, you know, probability of predicted category, something that I can choose. I can even give it a value that I want. But for this, let me keep it here. So I say scoring wizard, then I say function probability of predicted category. Next. Then it will ask give me a function that score the active. Then I say finish. Yeah. So now the new dataset DM3 has been scored, and I get a new field here which is predicted probability. So you can also see it here in the dataset. Yeah. So the new field has come, predicted probability. Yeah. So now, so when we click finish, I click then apply model to the active data set. Now these within this thing we can select the cases. We can select the cases which are meeting our condition of probability of responding more than 5%, and then click continue. Then we select the cases and copy them to create a new data set, and this new data set will have people whose probability of responding is more than 5%, and they are predicted as shown as people with response of my interest. And then we can use these people then can be used to send a direct mailer, and our direct mailer email response will be much better than what we could have achieved by sending email blindly to all the people in our contact database. So I hope you like this presentation on what are the different type of predictive models, what is the process involved in building a model and checking the performance and scoring a data set. You will find it very useful while you are doing analytical model building or analytical exercise in the business domain. Thank you very much.